Hello everyone. We have already covered a lot in this series on Microsoft Agent Framework. In part 1, we started with the grounds up. We explained what Microsoft Agent Framework is, how it evolved from the traditional SDK to semantic kernel, then Autogen, and now to this more structured and production focused framework. We created our first agent, understood different threads, tools, and the structured output, and set the base for everything that followed. In part 2, then we moved further or deeper, I would say. We talked about the serialization and deserialization, which let us save and restore the conversation context. We covered long term memory, which allows the agent to intelligently remember the key information across the different sessions. Then we added middleware, which gave us the visibility, security, and the control without touching the agent's core logic. Then we explored observability, which gives a clear end-to-end trace of what happens during the agent run. And finally, we integrated in MCP, which allows the agent to dynamically discover and use the external tools. So up to this point, we have built a strong foundation. We have an agent that's stateful, extensible, traceable, and secure. Now in part 3, we are going to bring it all together and make our agent feel more like a real application than just a smart chatbot. So before we jump straight into the workflows, it's important that we understand the core concepts behind the workflows. So workflows in Microsoft Agent frameworks are built on the structured architecture. At the center of it are the executors, edges, and typed messages as well as the events. So an executor is basically a unit of work. So it's a building block for the workflow. Each executor is responsible for a single task like loading the data or processing something or producing outputs. So executors talk to each other using the strongly typed message. This means that the data passed between the steps is well structured and predictable. Then comes the edges. Edges define the connections between the executors. They actually what makes the workflow. Whether the flow is linear, parallel, or conditional, edges are what tie everything together. Then there are events. Events give the workflow interactivity and visibility. They help us pause and resume, send output back, ask for the human input, and observe what's going on at a runtime. We can also use the agents inside the workflow or make the workflow itself act as an agent. And this is very powerful for orchestration. And on top of that, the shared state let different executors share the context without sending messages back and forth. Then there are checkpoints which allow us to pause and resume the workflows, and observability give us the full visibility of how everything runs. So these are the building blocks of the workflow. And now with the foundation, let's move on to the actual lab where we'll implement these concepts in action. So first question is, why the workflows matter? So in a real enterprise environment, your agent isn't just about answering the questions, it's handling the business process. So that often means the multiple steps, dependencies, parallel execution, conditional flows, and the human approvals. For example, onboarding a new customer isn't just one step. It involves collecting the details, running different verifications, provisioning resources, and sending the notification. Now, another example, approving an invoice might involve multiple checks in parallel and different actions depending on the amount, department, or the different policies of the organization. And many enterprise scenarios require humans to approve something before the flow can continue. And this is why the workflows are critical. They give you the structure to execute step by step actions in a sequence, or they can run multiple steps at the same time, use the different branch flows based on the logic or the rules. You can even pause and resume the human in the loop checkpoints and visualize everything clearly so that it can be audited or experimented or even explained. So now the first workflow is the sequential workflow. So it's the most basic type of the workflow. Here the workflow executes one step after another in a strict order. So when the step 1 completes, then step 2 runs, and then step 3, and so on. So in the lab, I'll walk you through a simple invoice processing flow. Under the hood, there are multiple executors, one for loading the configuration, one for reading the invoice data from CSV, one for calculating the totals, another for rendering the invoice text, and finally one for saving it to the output directory. All of these executors are connected using a simple edges to create a straight up step by step flow. The data moves forward, each executor picks it up, processes it, and then passes it on. And throughout the run, events make the entire process visible. And this structure is perfect for a linear process. For example, registration, onboarding, document processing, or any use case where every step depends on the previous one. So let's check this in lab. I have opened the VS Code now and I have created multiple files already. So, but before explaining the sequential workflow, I want to explain what we are doing here. So there is an invoice.csv file where are the different invoice numbers, the client information, and all those details are available. Unit price, quantity, and everything, how many invoices are there. So, and then there is an invoice utils.py. So what we are not using the AI agents directly here in this lab. However, in the end, in the last one, we'll use the AI agents. But here, I just want to explain the workflows. So this is a Python file which reads the file, the CSV file, reads invoices, do calculations and everything. So all those details are defined here. As you can read the invoices, calculate invoice total, and render invoice text. So our workflow will use this file to get more details about from the invoices. So now if I'll go to the sequential workflow file, it's first importing different variables and then it's importing executor, workflow builder, context, and workflow output event. So which are the core concepts behind using the workflows. Then it's importing the invoice util, so that means it's using the file which I just showed you, the Python file, loading the environment variable, and then it's showing the different menus. These are the helper functions which are defined so that this agent can run autonomous. This workflow completely can run autonomous. But what I want is to be more interactive so that you can understand how step by step it works. Now I want to show you how the executors are defined. So if I'll just quickly check. So these are the different executors. One is loading the configuration, environment configuration from the environment. Another one is reading the invoice from the CSV, then calculating the totals, rendering invoice, and the last saving the invoice. If we'll go to the edges, which creates the workflow builder. So now how the edges are defined, it creates a different workflow. So in this workflow, we are doing the sequential. So one after the another, all this will be done. As you can see, the different configuration which we have defined for the different executors, they will be run in a sequence. Then comes the events. So in the event, it's defined how you see the messages, typed messages and everything, all the information. It's for visibility. So you can see using that. So now let's run the workflow and see how it works. Open the terminal. So let me run Python number 16 file. So what it's doing is executor has run and it has loaded some values which we have defined here. So it's like what's the tax rate, high value threshold is if the value of the invoice is more than $5,000, high value discount is 5%, however preferred client discount is 3%, which we have defined in the invoices here. So whether the client is preferred or not, true or false it is. So now let's run the next step. It's reading the invoice. Which one do you want to run? Okay, because this is more than 5,000 as well as preferred customer. So let's run this 3. And now it has shown, okay, these are the values which have read from the file. Now let's do the calculations. Now it's doing the calculation. It has high value discount it has applied as well as the preferred discount. Everything is done through Python. So now the next step is rendering the invoice. It's creating the invoice. You can just quickly see, okay, what's the total value and everything. And the invoice is generated, however, it's not saved. And the last one, last executor will be, you can just save it. And if we'll go to output, there is an invoice which is created. So now using the workflow in a proper sequence, you have performed multiple steps. So here we have used the Python file. However, you can use the AI agents to make a decision, which we'll see soon in the coming labs. But in this part, we have done step by step in the sequential way. So let's move on to the concurrent workflow. Now in the concurrent workflows, instead of waiting for one step to finish before starting the next, the agent runs multiple tasks in parallel. So in the lab, after selecting an invoice, 3 executors run at the same time. One calculates the total, one prepares the client information, one performs a credit check. So something extra we are doing in this lab. Once all of the 3 finish their work, a merger executor collects their result and sends them down to the next path. So this is a great example of fan out and fan in execution. So the dispatch executor fans out the work to the different parallel paths, and then everything merges back into a single node. And this is all made possible because the framework handles the typed messages, edges, and the synchronization between the different branches. So this parallel approach saves time, makes the system more efficient, and mirrors how the real enterprise application operate, where there are multiple checks or the actions happening simultaneously. So let's check this in lab. Now in the concurrent workflow, we are just importing the same way from agent framework. We are importing the handler extra this time. And same using the invoice util file, which is the Python file. And then if I'll come to the executors, let's search. So there are multiple executors which are created. One is for loading and selecting the invoice, another one calculating the total invoice, then client information, credit check, and merges all everything, and finally saving the final invoice. So all this is handled by edges, which are fan out edges. So in the fan out, it's telling that these are the different activities or the different tasks which have to be performed in parallel. So these are performed in parallel by the edges, and then finally it's getting merged. So let's check this in action now. So the previous one, let's do no and open 17 concurrent workflows. So now which one to select? Let's select the 5th one. Okay, it's not a preferred client, amount is this much, and let's enter the parallel processing. So what it's doing is calculating the totals, preparing the client info, processing credit checks, and then all these 3 will be merged together and result will be provided, and it's saved. So now as you can see, the invoice is created with the client information and credit check. Everything is provided into the invoice and all those details are provided here. So now using the different core concepts, first we have seen the sequential workflow and now the concurrent one. And now let's move on to the next one. The third type is the branching workflow. This is where the workflow becomes decision aware. So instead of just going straight on or in parallel, the workflow chooses its path based on the different logic. So in the lab, when I select an invoice, the system analyzes it first. If a file for that invoice already exists, it automatically routes the flow through an archive branch. If it's a high value invoice, it routes to the high value branch where a different discount will be applied. If the invoice is for a preferred client, it takes the loyalty branch. And if none of these conditions match, it follows the standard processing branch. Now each of these paths are connected using the switch case logic behind the scenes. So this is made possible because the edges can be conditional. So the workflow engine dynamically decide which executor to route the message to. And in the end, everything converges again at a single point where the invoice is finalized and saved. And this kind of routing logic is what makes the workflow intelligent. So it allows the agent to follow the different business rules and the policies dynamically. So let's check this in lab. So now in this case, from the agent framework, we are adding something extra, which is the case defaults. So if we'll go to the executors, it's defined where it loads the invoice, handle the invoice, and do the different tasks which are defined here. Now if we'll take the edge, So now the different edge groups are created. As you can see, which are the different cases here. And the default one is, if these cases are not met, then automatically default one will be used. So now there is a condition which is defined, it's archived, then use this handler. So the different handlers are used, a high value or preferred, so the different high values, and it defines the different edges, how it has to be used. So let's quickly check how it works. So branching workflow, now we already have, for example, number 3. So let's use number 3. Existing file found needs archiving, so that means now archiving branch. So let's enter. So it's moved to archive, it's no more there, and it is gone to archive. Now if you'll press enter, then it is finding it's a high value customer and all those details it's processing, and then saving the output. So now again it has saved with all the discounts and high value discount, preferred client discount, and everything is provided. So the branching decision was, it was a high value, and all the reason for the discount and processing, everything is done. But this time, because it has made a decision based on there was file already present, and then the another decision was it's a high value customer. So based on all these conditions, these decisions are taken, are handled by the handlers and the different cases and the defaults. So that was all about the different branching workflows. Let's move on to the next one. The fourth part is one of the most practical, which is interactive checkpoint. So this allows the workflow to pause at a very specific point, wait for the human confirmation or the inputs, and then continue. So in the lab, after the invoice is prepared, the workflow doesn't just move on automatically. It pauses and asks me to confirm the tax amount. Once I confirm, it proceeds. And then it pauses again to confirm any discount that might be applicable. So all of this is powered by the request response events. So when the workflow reaches these executors, it emits a request event, saves a checkpoint, and waits for my input. And once I provide the response, it resumes from the exact same point. So this makes the workflow very resilient and collaborative. It can survive restarts because now you have checkpoints. From that specific checkpoint, you can restart again. Allow the human in the loop decision making and make complex approval processes very smooth. So let's check this in lab. So now in this lab, from the agent framework, we are adding something extra, which is request info messages, request response, file checkpoint storage. So file checkpoint storage is where we are saving and everything, but request response is the most critical one. As by default, if you go to the executors, it will show you what are the different executors, if they are processing discounts and everything. However, if you look for request response, now in different handlers, it's defined, like wherever there is a request response, that means the confirmation has to be provided, and it will wait for the human inputs. So now at 2 places it's defined. And then if we'll talk about a handler, so the different handlers are defined here for different stuff. And if we'll talk about the edge, so these are the different edges. Now these are sequential. However, what we are showing is these are sequential, though we are using a interactive approach, which is human in the loop approach. So let's check this quickly. Let's do no to this one. Let's run this file now. So interactive checkpoint. So what it's doing is it's asking us the invoice. Let's use the number 5. So now it has prepared some details and it's asking me to confirm the tax confirmation, yes, and then the discount confirmation. And once this is done, so what it's doing is it's creating the checkpoints. So whenever we are providing approval at that point, it's creating the checkpoint, so that for a long workflow, you can always retrieve at the same point when the approval was given. And if we'll go here, you can see the different checkpoints which are available. What are the different details of those checkpoints? So you can find here. And in the code, you can always retrieve those checkpoints too. But here we have just provided the human in the loop approvals as well as creation of the checkpoints. Let's move on to the next one. The fifth part is the workflow visualization. Executing the workflow is great, but seeing them clearly is even better. So in this part of the lab, we'll generate a mermaid diagram that shows the exact structure of the workflow. That can be the sequential flow, parallel flow, or the branching decisions. Because everything is built using the executors and edges, the framework can automatically visualize the entire graph. So this gives us a clear operational picture, which is great for documentation or debugging, governance, or even just explaining the architecture to the stakeholder in our organization. So let's check this in. So in this file, we are importing the variables, and from the agent framework, we are importing the workflow, which is the visual diagram where we'll use the mermaid to create the visual diagrams. So there are different helper functions which are defined, as well as the executors, as you know, for loading the invoices and the different tasks which has to be done. Now, because we are using all three workflows, which is sequential, concurrent, and the branching, so we have defined all those here. And apart from this, we are building a workflow. As you can see, different workflows are built, which are sequential, concurrent, and the branching. And then visualization workflow is created here, which shows the mermaid diagram using the workflow base. So let's test this. So now there are multiple options you have to choose. So I'll choose 4 so that all the options can be seen. Now you have selected everything, all 3. So let's press enter and done. All these visualizations are saved here. And let me quickly open the website which can open the mermaid diagrams. So the mermaidweir.com. So let's quickly use this, copy paste here. This is the branching one. So if we'll just copy paste here, and it shows the diagram like this. Now the same one for the parallel. It will show the dispatcher will start, then the tool calculator. So the parallel workflow it is, where the different executors are running parallelly. And the sequential, it's in the sequence. So first it's loading, then calculator, then rendering, then saving. So these are the different diagrams which are created using the visualization workflow. So let's move on to the next one. In this final part, we'll take everything a step further by bringing the agents directly inside the workflow. So instead of just using the fixed executors, some of these steps now will be handled by AI agents, so making the workflow both structured and intelligent. So in this lab, the run starts by letting us choose which invoice to process. Once I've selected the invoice, the workflow passes this to an analysis step powered by an agent that specializes in invoice analysis. So this agent reviews the invoice amount, checks discount, evaluates risk, and provides a clear explanation that logs into the console. Then the output from this step goes into the business decision agent. The agent decides how to process the invoice. For example, whether to mark it as priority, review required, or the standard processing. So I can confirm or override the decision here, which adds the human approval element into the flow. So next, the invoice and the decision are passed to the communication agent. This agent provides a personalized client email, and I can select the type of the message, whether it's an invoice acknowledgement, payment reminder, or the thank you note. So once I approve the content, the workflow saves the email in the output folder and can optionally trigger an email integration by sending an email, which we can do, which we are not doing in this lab, but we can do it like by integrating directly to the logic app or something. Finally, we'll use the summary agent to produce an executive summary of the entire run, capturing the analysis, decision, and communication in a concise format. Then the workflow saves this as a part of the final report. The overall flow is very clean and simple. What makes the lab special is the intelligence, because Now, instead of the fixed executors, Python executors, we are just using the AI agents. So let's check this in lab. So now in this file, we are not importing anything special. So all this we know. And these are the different executors. There will be different executors which are analysis agent. However, the catch here is that we'll create everything using the Azure AI Foundry. So when we go to Azure AI Foundry, so we have deployed the model GPT-4o, and right now there are no agents. If I'll click here, automatically one new agent will be created. Let's delete this. So there are no agents right now. And we have provided those details in the environment file. So if we'll go here, .env01, so we have provided the endpoint here. So let's quickly run this. So now there are 8 invoices which are loaded, and now what it's doing is agent analysis. So a new agent is being created which will do the analysis on INV001. So here I'm not choosing the invoice, I've just selected it by default, and now as you can see it has done some analysis on it. Then another agent which is making a decision whether it's a high priority or what level of decision has to be done, so it has taken the decision. Then the next one, it's creating the email, and finally the agent summary and all the summary and the workload output. Now it's saved here. So if we'll go to the output, so agent report is saved which shows everything, all the details what have been done here, and the email which is created, and all those details like invoice acknowledgement email. So here, because I have kept it autonomous, we have already seen how interactive we can make it in the other files. And for this one, I just wanted to show that if we want to create a workflow, we can just create it using the AI agents. And now let me quickly show you if the agents are created here or not. Okay, I think in the end it's deleting the agent. Yes, I have set up that option. Yes, it deleted all these agents. So these agents were created, however, because these are temporary agents, we have deleted them. So now I have kept it all autonomous, all the agents here. However, you can use the mix of both. You can use some, for example, MCP server, or you can use the calculator function, the Python function, as well as the AI agents, where the decision has to be taken, smart decision or intelligent decision, you can use that. So that's all about the lab. Now, beyond this series, there are more labs we can add to take this even further. We can build a shared state lab where multiple executors share the same context without passing the messages every time. We can even expose a workflow itself as an agent, as well as explore the observability in detail so that we can know exactly what happens during every run. And finally, you can also look at the orchestration on how to combine the multiple workflows together for more complex enterprise use case. And with this, we have reached the end of the series on Microsoft Agent Framework. So at this point, you have everything you need to build the production ready AI agents using the Microsoft Agent Framework. So this series was designed to give you a complete end-to-end view of how to go into a simple chatbot to the structured, intelligent operational AI system. I hope you liked it. Please like and subscribe. Thank you so much.